Our newest project at LED Performance is adapting a 350 Sphinx power valve cylinder to the CR350. This kit is going to work on the older CR350s, 2001 and earlier, and we have not yet developed a kit for the newer case reed motors. So today we are doing our base runs on this engine so that we will be able to compare the horsepower and torque between stock and build. So the base bike that we're using is a stock 2001 CR350, has an FMF pipe and spark arrested silencer and B-force reeds, and so that's going to be our base. This will be our base runs. This is the beginning of that series of tests. So we jetted the carburetor and so that it will make the most power it can make, and once we're done doing our base runs, then we'll tear the bike apart and then we'll have good comparisons. So in order to have a wide power band, both cylinders use a power valve. The stock Honda uses a power valve that's operated by a linkage, and there's a generator in the bottom end, a centrifugal generator that can open and close this mechanism to raise and lower the exhaust port according to RPM. So at low RPM, the gate valve is down, lowering the exhaust port. On this cylinder, on the new Sphinx cylinder, we're using a power valve as well, but it uses an entirely different style. It's actually a Rotax gate valve, and it uses exhaust pressure being emitted into this bellows, which causes the valve to open and close according to RPM. It's got a gate valve that goes into the cylinder like this and lowers the exhaust port. So at low RPM, it gives you good low end because of a low exhaust port at low RPM, and then at high RPM it comes up like this, and then you have a ton of top end. The exhaust channels up through these slots in the gate valve, goes up into this bellows, and that's what raises and lowers the exhaust port. The Rotax style gate valve is a favorite of mine because it's very simple. It doesn't require any linkage or any kind of a centrifugal generator on the case, and it always works. And it's easy to service as well. They don't fail and they just work out well. The cylinder head has a removable combustion chamber. So it's an open casting like this. The head itself is sealed with O-rings. And here is a comparison between the stock head and the Sphinx head. Sphinx head's on my left. There's some big differences beyond bore size. If you take a look at the CR350 cylinder, it has a very conventional port arrangement. We're all used to seeing this. You've got 5 transfer ports. 1, 2, 3, 4, 5. You have a oval exhaust port with 2 flanking boost ports. These are the flanking boost exhaust ports right there. So that's a pretty conventional setup. It uses it has a power valve, and the power valve is in the port, raises and lowers the exhaust port right here, and it's run, this one's mechanical, it's run off of a power valve generator in the case. We disable the stock power valve. We don't use any of the stock power valve linkages or anything. We're using a different style power valve. The Sphinx cylinder is not very conventional. It has a big oval exhaust port. It's sort of an oval shape. It has 2 flanking boost ports, but it has 2 more transfer ports. So in order to do a better job of scavenging, one of the reasons this thing makes so much power at such a low RPM is because it has a very sophisticated transfer port setup. These transfer ports control the fuel charge. On a 2-cycle engine, scavenging is really more important than airflow, but this cylinder flows a lot of air. The transfer ports are aimed in such a way that the fuel charge adheres first to the top of the piston, and then it forms a good coherent column up the back of the cylinder wall. And having all these smaller, relatively small ports allows you to really control the stream, the transfer port streams. So if you had a bigger transfer port, it would flow more air. If you say you didn't have dividers in here, but the air wouldn't be nearly as organized. So this is really specific on how the fuel charge flows into the cylinder. And the trick to having a wide power band is being able to keep the fuel charge in the cylinder at low RPM, at relatively low RPMs when the exhaust port is wide open. The CR350 is ready to go. We got it all back together again. We got the pipe built. It's a 78 millimeter bore Sphinx cylinder. We're running the stock 72 millimeter stroke, and we're running the stock 125 millimeter rod. And if you look at the dyno chart, we've made a couple of passes, and we'll make another pass here, but this is how we started. This is the stock motor right here with a FMF pipe, but and a B-force reed cage, but other than that it was stock. And the line right here is a couple of runs with the CR350 cylinder, Powervalve cylinder up and running. So you can see there's a pretty significant gain in horsepower. The CR350 is making 60 horsepower, and as a stock 250, it made 46, so we've made a pretty good gain in horsepower. So now we're going to fire it up, and we're going to do another run on the dyno. It has one of our hand cone pipes. It requires a different pipe than the stock cylinder, really, for best results. The new pipe is one of our hand cone pipes, made out of 28 different individual cone pieces. And we also made one of our round-bodied silencers. The pipe is important because the engine is so much bigger, moves a lot more exhaust, makes a lot more horsepower, so tailpipe size needs to be different. It also has a different header size and different cone angles over the stock pipe. All in all, this is we feel like this is a very successful package. The motor's very rideable, and it's a huge horsepower increase over stock. I think I'd rather ride this than a CR500. It certainly makes as much or more horsepower.